Well, hello to everybody. I'm Andrés. I'm working in IA with Miriam Del Rio's group, and I'm going to talk to you about the understanding of natural regeneration of Pinus pinaster in the south of Spain using different regeneration cuttings. Well, climate change is one of the most concerning problems in the nowadays society. But this was the reality of the Spanish forest 100 years ago. However, during the 50s and 60s, a massive plan of regeneration was performed in the Iberian Peninsula, leading to more specific, even age and absence of forestry treatment forests. So our society has now to deal with these problems. Climate change is going and it's performing some synergy problems with all these other problems that I told you, and can perform more fire risks or higher mortality risk due to pests. So it is important to have a natural regeneration and diversification of our stands. Here we have Fuencalente's forest, Mount number 6, and it's a Pinus pinaster stand of more than 65 years old, and it's going to be the main character of this presentation. Well, the aims of the project are to understand the most efficient way to overtake the 80 to 120 year rotation and start regenerating the forest. Then diversify in terms of age, structure, and species, creating a more resilient forest to climate change. And finally, understanding the ecological succession of the reforested forest and identifying the constraints of the natural regeneration. Here we have our forest. In 2017, it was a forest of 320 trees per hectare, and we divided it in two treatments. The first one was the seed tree method, and the other one was the group selection treatment. So after 2017, this was the end after the treatment. So in the seed tree method, we placed 14 20-meter radius plots here, and we left 35 trees per hectare. And inside of those plots of 20 meters, we placed 1 meter radius plots, subplots, corresponding to the north, west, south, and east, and the center of the plot. On the other hand, the group selection treatment, we create from 62 to 36 meter radius gaps, corresponding to 2 to 3.3 times the dominant height, that was 18 meters, and inside of them we placed 21 1-meter radius subplots, corresponding to this image that you have here. In the principal, the secondary cardinal radius, and 4 outside. 2 in the most sunny part, 2 in the most sunny part, and 2 in the most shade part. I also have to say that the broad leader species, such as Quercus pyrenaica, Phaginea, Quercus ilex, and all these species were not cutted. So, how did we do the measurement? Well, all the winters, we went there from 2018, and this was our unit of sampling, the 1 meter subplot. This is how it looked like, and what we were looking inside. Well, the first thing were the less than 1 year pines, or also known as seedlings, and the more than 1 year pines, or saplings. How do we know that one pine is a seedling or one pine is a sapling? Because sometimes they are mixed. Because we name, we measure, and we locate each seedling each year, so the next year, if it is still there, it will be a sapling. Also, we measure the shrub cover of shrubs like Cisullanadifer, Erica, or aluminum species, and also other abiotic factors as stoniness or the litter. Well, going through the results, here we have the densities, here the seedling, and here the sapling, the less than 1 year, more than 1 year, and with the both treatments. Here we can see that the first 3 years, more or less, the two treatments were almost the same in terms of seedlings per hectare, but since 2021, with the seed tree method, the one that left some trees in the stand, we had more seedling production, more offspring. However, the important thing when we're talking about regeneration and natural regeneration are the sapling densities, because they are the trees that have been stabilized, the more than 1 year. And we can see a big difference between the both treatments. I have to say that both treatments are not statistically crossable, but we can see that there are two different tendencies. And finally, that the group selection system is improving, but slower. But it's improving. When we look at the densities, we can see a frozen image, but we want to see the process. So we can look at the survival rates, and this is why we differentiate between seedling and sapling. These two lines correspond to the survival rates of seedling, and these two correspond to the survival rates of sapling. We can see that there is a big constraint between the first and the second year. If the tree can pass the first year, can stabilize and establish, the next year will have more opportunities to not die. So this is very important. And also I have to say that between both treatments, here we have the seed tree method, in seedling and sapling, the survival rates are higher. But why do we have these results? Because if you think in the group selection, you have big gaps, but they are protected by the rest of the forest, that it can provide shelter against the wind, the cold and the warm temperatures. Also, having more trees in the surroundings can provide more pine cones, so there are more seeds, so there can be more seedlings. Well, we haven't statistically analyzed this, but one of our hypotheses can be the shrub facilitation process. If we look here, we can see the shrub cover percentage, and we can see that in the seed tree method, it's almost 4 times higher than in the group selection. So this can show us that for the little pines, the shrubs can give less insulation and less everybody because they are not palatable plants, sorry. And finally, the discussion. I told you one of the aims was the diversification of the stand. And here we have a graph of 2023 with the percentages of the three with the pine and other species. Here we have the seed tree method and the proportions of seedling and sapling. And as we can see, there is a better pine regeneration if we look at the one that we want, that are the sapling, here in the seed tree method. However, we can see a more diversification with the group selection. Here we have more other species, like mainly quercus. We can differentiate them. And finally, why can be this? Because inside of that forest, we found more other species, so the seeds can go there easier. And finally, we can see that our forest is regenerating slowly because we have other the same project, but in other parts of Spain, and it's going faster than here. However, it's going slower. And finally, I have to say that our final aim is to model the first constraint, that is the first year, the pass of the first year of the little pine, and then model how it stabilizes and creates a forest. And that's all. Thank you so much.